This is Terry Escobar at Santa Clara University, and you are watching Excel, the payment function. To calculate a loan payment in Excel, you can use the payment function. The payment function calculates the payment for a loan that has a constant payment and a constant interest rate. Let's review the payment function and the payment function arguments. Payment function is equals PMT. The first argument is rate. This is the interest rate for the loan, but it's a periodic interest rate, which we'll talk about later. NPER is the total number of payments for the loan. PV is the present value of the loan or the total amount that you're borrowing. In our example, it will be the total amount or cost of an item minus the down payment. FV and type are both optional arguments, but for your own information, FV is the future value or cash balance you want to attain after the last payment is made for the loan, and type determines whether or not you're going to pay at the beginning of a period or at the end of a period. These two optional arguments we will not cover in this class. In this example, we are going to calculate the monthly payment for an item that we're purchasing for $800,000. So let's say that we're purchasing a house. That would be around $800,000. Column B will be a scenario where we are given 5% interest. Column C is a scenario where we're given 3.5% interest. The cost of the item is $800,000. We've decided to put a down payment of $80,000, which means we're borrowing 800 minus 80. So let's calculate that. Equals 800,000 minus 80,000. So we're borrowing $720,000. We're borrowing that money for 30 years at an annual interest rate of 5%. So let's go ahead and calculate the monthly payment for an item that we're borrowing $720,000 for 30 years at 5%. Equals PMT, open parentheses, the rate. Now remember I said this is the periodic interest rate. If we're going to be paying this monthly, that means we'll be making 12 payments a year. So it is the annual interest rate in B7 divided by 12. Arguments in a function are separated by a comma, so I typed a comma. NPER is the number of periods. So we said we're taking this loan out for 30 years in B6 multiplied by 12 payments a year, comma, and the present value of the loan is $720,000. Now we're not going to determine the future value or type, so we'll close that parentheses. You can see that those are in square brackets, so you do not have to put them in or they're optional. I hit enter, and the cash flow is negative, so the payment function gives us a negative number of $3,865.12 per month. If for any reason you want to see your cash flow as positive, you can come up to your formula bar and make the present value of the loan a negative reference. So now we have $3,865.12 and a positive number. Well, let's see how much the total cost. So let's go ahead and click in A9 and we'll put total cost. I want to know how much I'm spending. So that would be equals, simple math, how much I pay every month multiplied by 12 months a year multiplied by B6, how many years I am taking the loan out for, and I hit enter. So that $720,000 loan is now costing me $1,391,441.65. That might be too much for me. Let's copy this scenario to column C. Again, we're leveraging relative cell addressing, so our math remains sound. We're simply going to change our percentage to 3.5%. So that's 0.035, and when I hit enter, that takes our monthly payment down to $3,233.12, and it takes our total amount down by about $200,000 and some change. What if I was really trying to get my monthly payments below $3,200? Well, let's take a look at one more scenario. We're going to copy our test into column D. And so this is identical to column C at the moment, but I'm going to say with double down. So instead of making an $80,000 down payment, I'm going to multiply that down payment times 2. So $160,000 down payment. Now I'm well below that $3,000 mark, and I'm very close to the total payment of the loan being at $1 million. Thank you for watching Excel, the payment function.